Hi, I'm Landon Vogt.
I'm Maverick Pilikowski.
And Daniel Webb is our third member. However, he was unable to attend this demonstration of our robot. For our project, we chose to design a robot that would shoot darts at a predetermined location on the dartboard. We picked values 1 through 3 to be single, double, and triple value points, and then values 0 through 20 to be 0 being bullseye, and then the rest being with the corresponding numbers. This is the design of our robot, and as you can see, our robot loads through the muzzle, and we have a ramrod here to push the dart down into the desired firing location. Once the dart is loaded, we can come to our code and press R to generate a random target to shoot at. We have 777 that is going to aim at. We press A to aim the robot and get a pressure reading, and then we press F to fire in 3, 2, 1.
As you can see, the dart did not hit the intended target of 777. So our robot has a margin of error, and to determine the accuracy of our robot, we aimed it at the bullseye and took 20 different dart readings and saw where they were on the board. We found that in the X range, the dart was at max 4.5 and -7.3, and in the Y max range, it was 5.3 to 7.7. But on average, we found that the dart was mostly accurate, and it was around 1.8 in the negative X direction and 1.8 in the Y direction. And we experienced a bell curve after calculating all these values. We can attribute a lot of this error to the robot not having the right equipment to handle this. So we believe there's a lot of friction that the dart experiences as it travels through the barrel, and this goes off our calculations, along with the servo motors. When picking a theta and being locked in place, they have a bit of give that change the X and Y displacement of the barrel. And since our dart needs to travel a long distance and the target is not very big that we're trying to hit, it causes it to be very dependent on the theta values, and these motors give great displacement in where it lands.
So now we will test fire the robot again. First by hitting R and getting a randomly generated target. We are going to go for 13 here. A will aim the robot at 13, and F will fire in 3, 2, 1.
As you can see, it did not hit 13, but it is in the range of our margin of error.
If we were to improve the design of our robot, we would first start by making the barrel of the robot detachable so that the barrel could be cleaned in between shots. This would reduce the friction and allow that theta angle to be calculated more closer to correct. We also would get more precise motors that can output a more precise theta value and hold the robot so it doesn't have so much wiggle and won't miss left or right as much. Thank you.
Thank you.